Good evening. If everyone would grab their seats, we'll get started. My name's Randy Hollerith, and I am the Dean of Washington National Cathedral. And on behalf of Mary Ann Buddy, the Bishop of the Diocese of Washington, and all of us who serve this cathedral, welcome. We are so glad to have you with us. This cathedral is a house of prayer for all people, and you are always welcome here at any time. Convening conversations, bringing people together to discuss and examine important issues of the day is one of this cathedral's core priorities. Since 2008, the Nancy and Paul Ignatius program has given this cathedral an opportunity to focus on a number of important issues that sit at the intersection of faith and public life. We're deeply grateful to the Ignatius family for their generosity and their support and their good work. Would you please take just a second and join with me in giving Paul Ignatius and his family our thanks for this program. Our topic for this evening is one that has fascinated me for as long as I can remember. As a member of that generation of young people who were deeply impacted by sitting in front of our black and white television sets, watching Neil Armstrong set foot on the moon, the question of our future in space has always been an important and persistent one. Moreover, as someone who could not wait to see what would be discovered each week on the final frontier, I grew up knowing what this meant before I knew what this meant. So live long and prosper, everyone. But more importantly, it seems especially appropriate to me that we should be holding this conversation here in this cathedral. After all, we have an extraterrestrial treasure that is built right into the fabric of this building. As one of our panelists for tonight's conversation, Dr. Wilkinson, so eloquently wrote in his book, Science, Religion, and the Search for Extraterrestrial Intelligence, a book, by the way, I highly recommend. In his book, he wrote, quote, "In Washington National Cathedral, the stained glass space window features a moon rock returned to Earth by the crew of Apollo 11. This 3.6 billion year old rock is encased in an airtight nitrogen-filled capsule in the window, which features stars and orbiting planets. Armstrong, Aldrin, and Collins delivered this 7-gram sample from the lunar Sea of Tranquility during a ceremony here at the cathedral on July 21st, 1974. On that occasion, Neil Armstrong said, "On behalf of the President of the United States, we present unto you this fragment of creation from beyond Earth, to be embedded in the fabric of this house of prayer for all people." Now, finally, as J.B. Phillips reminded us almost 70 years ago, we must be careful not to have a view of our God that is too small. Because I believe the great mystery that lies at the heart of existence, the God who is, we say, the very ground of our being, that God beckons us into the great mysteries of the universe, where we can discover, I believe, divine footprints wherever we go. After all, the Bible teaches us that God created all things, and that God created all things good. So let us venture out into God's good creation, because we never know what we just might find. Thank you. Now it's my privilege to introduce Mr. David Ignatius.
So, thank you, Dean Hollerith, on behalf of all of the Ignatius family, I'd like to welcome you to tonight's forum. When we're in this magnificent cathedral, we're always looking toward the heavens, but we thought tonight we'd make it a practical conversation rather than a prayer. A word about this forum. More than a dozen years ago, my siblings, Sarah, Amy, Adi, and I worked with the cathedral to establish an annual program to honor our parents, Paul and Nancy Ignatius. Our mother, who passed away 2 years ago, was devoted to the cathedral. With her inquisitive mind and spirit, she would love the subject of tonight's discussion. Our father, Paul Ignatius, is very much here with us tonight, sitting in the front row. He will celebrate, I'm going to reveal our family surprise, his 101st birthday tomorrow. The U.S. Navy, with which my dad served in combat during World War II and later as Secretary of the Navy, honored him last week with the Distinguished Service Medal, the Pentagon's highest civilian award, so we celebrate with him tonight. The speakers at our first forum in 2008 were Zbigniew Brzezinski and Brent Scowcroft. And since then, we've had many of America's most distinguished public servants share their thoughts here about how to make the country and the world better in ways that reflect our values and our shared destiny as a country and a world. Tonight's program is special in that we're going to think not about our dilemmas down here on Earth, but about the opportunities and puzzles out there in exploring our future in space. We've organized the discussion in 3 parts. First, I'll have a conversation with 2 of our most senior government officials who think about space, NASA Administrator Bill Nelson, who will be joining from the 4th dimension, as I'll explain in a moment, and Director of National Intelligence Avril Haines. Then my brother Adi will have a one-on-one chat with a recent astronaut, Jeff Bezos, chairman of Amazon, founder of his own space launch company, Blue Origin, and also, not least, the owner of my favorite newspaper, the Washington Post. Then we'll have a final panel discussion led by Dean Hollerith with 2 scientists, Professor Avi Loeb of Harvard University and Professor David Wilkinson of Durham University in Britain, who studied the scientific and religious puzzles that surround the possibility of extraterrestrial life. What's our baseline about humanity in space? Well, the character Calvin says in the comic strip Calvin and Hobbes, the surest sign there is intelligent life out there in the universe is that none of it has tried to contact us. We will disprove Calvin's line about intelligent life on Earth tonight. I'm certain of that. From Sarah, Amy, Adi, and David Ignatius, and especially our father, Paul, thanks to all of our speakers and our audience for joining us here tonight in person and online. Now, I'd like to ask Director of National Intelligence, Avril Haines, to join me on stage. While my mic still works, I introduce our other absent, but also, if the technology works, present panelist, Senator Bill Nelson. Senator Nelson was called away from Washington this morning with the ultimate excuse for a NASA administrator. A Martian didn't eat his homework, but because of the launch of SpaceX Crew 3 and its 4 astronauts to the International Space Station, which was rescheduled for tonight from what was going to be a launch tomorrow night, he obviously had to go to Florida. Senator Nelson, sensing that this might happen, taped answers to my questions yesterday before he left. So he's here with us by screen. In addition to being the NASA administrator, I should tell this audience he's a former senator from Florida, an astronaut himself, who flew on the 24th mission of the Space Shuttle. Avril Haines, who's here with me, is the Director of National Intelligence, overseeing the CIA, FBI, National Reconnaissance Organization, and all the 18 agencies under her wing. She is truly a modern Renaissance woman, with a first degree in physics from the University of Chicago, a law degree from Georgetown, and experience as a judo fighter, a car mechanic, an apprentice pilot, the owner of an avant-garde bookstore, and then in government as an appellate law clerk, State Department official, a member of the White House Counsel's Office, Deputy Director of the CIA, Deputy National Security Advisor, and now Director of National Intelligence. So welcome to DNI, Haines. I want our audience to think of tonight's conversation, again, assuming the technology all works, as a multi-platform bit of time travel with Senator Nelson, who gave these answers yesterday. Let's start with Senator Nelson. Matt, our technician, if you can make this technology work, roll it. Senator Nelson, you're unique among our panelists as an astronaut who orbited the Earth in 1986 on the Space Shuttle. To open our discussion tonight, tell us what you saw as you gazed out the window during those 98 orbits of the Earth, and what thoughts you had about life on our planet and the possibility of other life in space.
The Earth is so beautiful. It's so colorful. It is this magnificent creation that is suspended in nothing. And space is nothing. It's an airless vacuum that goes on for billions and billions of light years. And there's our home. I had several reactions as I would float to the window, by the way, usually during our sleep period, because every minute is planned. And I'd cheat on my sleep so I could float there in front of the window and just soak it in. I was struck how fragile it looks. I would look at the rim of the Earth, that bright blue band, and right underneath it, I could see the atmosphere and realize that that sustains all of our life here. And then I could see, actually, from this perspective, 36 years ago, I could see how we were messing it up. Coming across Brazil, I could see the color contrast in the upper Amazon region, and then I could look to the east at the mouth of the Amazon and see the silt for hundreds of miles out into the Atlantic. Or coming across Madagascar, back then, they had cut down all the trees. There were no roots to hold the topsoil. So when the rains came, all of the topsoil ran down the rivers, and there it was very clear, looking at the mouths of the rivers in the bright blue waters of the Indian Ocean. And there was all that silt. It made me want to be a better steward of what we have. But there's one other lasting impression I want to tell you about. Because I was a policymaker, I was a politician, and I looked at the Earth as we orbited every 90 minutes. I did not see racial division. I did not see religious division. And I did not see political division. What I saw from that perspective, looking back at our home, I saw that we were all in this together. Now, if we have life on this earth, to answer the second part of your question, do I think in these billions of stars that are in our galaxy, and there are billions, if not trillions, of other galaxies, is there the opportunity for another star, a sun, to have planets going about it Yes, I think that. Who am I to limit life right here?
So, D.N.I. Haynes, you began as a theoretical physicist, as I mentioned in introducing you, but you now have the very practical responsibility of running the intelligence community. Nearly all the agencies that you oversee as D.N.I. have some space-based activities in communications, command and control, intelligence collection. I want to just ask you what guidance you give to your agencies about our vulnerabilities, our missions in space, and I also want to ask whether your agencies are looking, collecting, in the parlance of the intelligence business, for early signs of life out there.
So first of all, thank you. And it's hard to follow Bill. He's so spectacular on these issues. And I can't think of a more uplifting location from which to have a conversation about space. I'm a child of the 60s. I grew up watching Star Trek, and I frankly love it. And it's one of these things where, you know, as Bill indicated, it's hard to overestimate rather the inspirational aspect of space and the fact that, you know, it drives us to innovate in ways I think that it's hard to match in other domains. So for me, in terms of our collection in space and what it is that we're focused on, we are focused generally on life on Earth, and that tends to be where where we invest. But it is something that I think, as you indicate, we're still exploring, and we're trying to understand what this domain can be for the future for us. And I think that's as we're developing, not only are we focused on life on Earth, but we're also seeing how, frankly, life on Earth is developing in space, and we're recognizing that it is going pretty quickly this decade, and I think we're going to see a lot of changes in the future.
So we'll come back to the specifics of your involvement in space with a very particular report that you authored. But I want to ask Matt to roll the second question that we put to Senator Nelson. Senator Nelson, NASA just announced a new project to work with the scientific community to assess, are we alone in the universe? What do you hope to accomplish?
Well, I've asked our science mission director to propose a series of scientific goals as we look out for life in this universe. First of all, we're looking for life right now. That's why we have a probe on Mars. It's a big rover. It's as big as a Range Rover. It's got an arm, and it goes out and it drills holes and it puts it into a titanium tube. And we're sending a mission that is going to go there and pick up those tubes filled with cores out of the Martian surface on that lake bed and near where it is obvious that a stream came down into that lake bed at one point. And we're looking for signs of life there. We're looking for signs of life as we have these telescopes, the James Webb telescope going up in December. It's going to be positioned 1 million miles from Earth. And it's going to look away from the sun, and it'll pick a keyhole, and it'll look through it, and it'll look back into capturing light from 13.25 billion years ago. That's almost to the time, 250 million years after the Big Bang. And we're going to see what we discover as it picks another keyhole and looks in there and trying to see planets in our galaxy, but maybe other galaxies that have a sun, and suddenly there's a dark spot moving across that sun, which would indicate a planet. And then we're going to try to get the chemical composition. So Do I think there's life out there? Yes. I cannot limit this universe to be just here.
So, D&I Haynes, on this topic of life out there, you issued an extraordinary preliminary assessment in June on unidentified aerial phenomena, is the new term of art. To summarize that report, you studied 144 reports from U.S. government sources. 80 had multiple sensors that had made the identifications. In 18 of these instances, observers, I'm quoting, reported unusual UAP flight characteristics. You sorted these into 5 different bins. The last call just other. I want to ask you to share with the audience your takeaway after the completion of that report and what your own view is as you look at the evidence.
Yeah, I mean, I think the bottom line is that we don't understand everything that we're seeing, and that's probably not surprising to anybody in many respects. But it was a report that really, Congress asked us to produce a report that assessed what we saw as the threat, essentially, from unidentified aerial phenomena, and what our sort of best understanding was of the different reports that we had identified. And it stretched over from, I think, 2004 through to 2021. The different reports that you indicated, 144 of them. And we had different categories, as you said. So one of them was airborne clutter, another was natural phenomenon, another was foreign adversaries, a fourth one was related to sort of US government or industry developmental programs, and then the fifth one was other. And that basically indicated that we were pretty sure we weren't going to be able to characterize every single one of these reports in the various categories that we'd identified because, frankly, we were not able to understand everything about it. And a large portion of that is based on the fact that we don't have a consistent way of reporting this information. We need to integrate, frankly, a lot of data that we get. We need to get better at collecting information that's useful to us from different sensors that are available to us, and we have to deepen our analysis in these areas. And that's something that, frankly, probably also doesn't surprise you in the sense that that's how we typically approach our intelligence work. And the main issues that Congress and others have been concerned about are basically safety of flight concerns and counterintelligence issues. But of course, there's always the question of, is there something else that we simply do not understand that might come extraterrestrially?
Let me just ask a follow-up question. I'd love to hear your comments about what the tradecraft of UAP detection is. How we'll know what we know. How would we know if we were being observed, for example? That's, I find, a question people pose to me often in the weeks before this session. What is the tradecraft?
Well, the tradecraft isn't any different for unidentified aerial phenomenon than it is for the rest of our work in the intelligence community, which is to say that, we do our work very much as I was indicating. We sort of, collect all of the information we can through a variety of different sensors. People are reporting things, we're picking up things technically, we're doing a variety of work to try to understand what it is that we're seeing. We are then taking other information that we have to determine, is it something that we know about in that area? Is there some other reporting that we might not normally think of as being connected? And then we do our analysis as we normally would to sort of say, okay, put it into context. What are the likely possible options? How do we characterize it, bucket it, and think about it? All of that is sort of the standard way in which you work. But it doesn't mean that that we are definitely going to be able to tell if we're being observed under the circumstances. I mean, I think there's a lot of different ways in which that might be revealed, but certainly we're working to make sure that we understand what we do see and what phenomenon is identified, and otherwise we're going to have to wait for Bill's science work, I think, to actually reveal some of these additional possibilities, not to mention some of the other people that I think you'll talk to later today.
So let's turn back to Bill, who discusses that in his other remarks. Matt, let's roll the next clip from Senator Nelson. Senator Nelson, the Artemis program is scheduled to return humans to the moon by 2024. What do you hope to accomplish as we return to the moon, and how does this pertain to our hopes to visit Mars?
Well, right off the bat, we are going to land the first woman and then the first person of color. Artemis, by the way, in Greek mythology, is the sister of Apollo. Apollo was over half a century ago. This now is the Artemis generation. That's the first thing we're going to do. But we're going back to the moon to try to learn what all we need to do to sustain human life under very adverse and hostile conditions as we get ready to go to the planet Mars. And when we go to Mars, we're going to continue this search of understanding who we are, where we came from, and what was before us, and may be foretelling of what is the future. I think establishing colonies on the moon is the preparation that we need to go to Mars, because the moon is only 250,000 miles away. We can get there in 3 or 4 days and get back in 3 or 4 days, a relatively short trip, and we showed that we could do that back in the Apollo program. Mars is a different story. Mars, you got to get the planets aligned correctly to have the shortest distance, and unless you go there real fast with new propulsion technologies, which we are developing but not developed yet, unless you can sprint there in, say, 40 days, if it takes you 8-10 months to get there, you're going to have to stay on the surface for quite a while in order for the planets to realign to be able to get back in that period of time. So we're going to the moon to learn what we need to do as humans to survive when we go millions and millions of miles out to the planet Mars.
So, D&I Haynes, space is now, sadly, a military domain. Russia and China have tested anti-satellite weapons. The Chinese are reported to have one satellite they call the Shijian-17 with a robot arm that can pluck satellites out of orbit, in theory. How serious are the threats to our space-based architecture, civilian, military, intelligence? And what are the intelligence community and the Pentagon doing about that threat so that we're better protected?
Yeah, so first of all, I mean, our space-based architecture we rely on for domestic and international commerce. We are beholden on it for our homeland security. It's quite intertwined with critical infrastructure, for example. So there are 55 critical functions that our Department of Homeland Security has identified as critical, and really all of them are connected to space in a variety of ways. It is critical to our national security, our military capabilities that rely on space, and it's critical to scientific discovery, as we know. And so it is fundamental to so many different aspects of our life and our interests. And yes, the threat is real in the sense that both China and Russia are increasingly building space into their military capabilities. They both have both ground-based and space-based counter-space capabilities. They have effectively counter-space capabilities that allow them to jam some of our satellites. They have directed energy weapons that allow them to essentially blind sensors on various satellites. They have, in the context of, for example, China has a anti-satellite missile that is capable of attacking satellites in LEO, in low Earth orbit. So there's a variety of concerns in this area. And in terms of what we're doing about it, We are absolutely committed to protecting, frankly, access to and the capacity to explore space for a variety of nations, ourselves, our allies, our partners around the world. We recognize how important this is to our collective human prosperity. And therefore, we're looking to defend our architecture and make sure that, in fact, it's capable of being resilient through these periods.
Matt, let's hear what Senator Nelson had to say about these tensions, great power conflicts. Senator Nelson, at a time of rivalry and tension here on Earth, do we need more joint space missions with rivals like Russia and China?
If ever there's been a success between nations that were hostile on the face of the earth, it's between the Soviet Union and the United States in 1975 in the middle of the Cold War. An American spacecraft and a Soviet spacecraft rendezvoused and docked, and the crews lived together. And they did that for 9 days. And even though we have our terrestrial problems with Russia, a la Putin and his government, we are cooperating in space. And remember I told you about that Apollo-Soyuz? That was led by General Tom Stafford and General Alexei Leonov. Those two, after that mission, became such friends that over the years, Alexei helped Tom adopt 2 Russian boys who are now out of college. And when Alexei died a couple of years ago, who was asked to give the eulogy? None other than Tom Stafford. I think that shows you what we can do. We're not having that success with the Chinese government. They've been secretive, non-transparent. They have not wanted to cooperate. And yes, we could have some trouble in space vis-a-vis the Chinese.
D.N.I. Haynes, I want to ask you to take that question to the next level. Intelligence is about thinking about the unthinkable. It's about measuring risks that are over the next couple of hills. When your analysts think about a world, a solar system where we can imagine colonies on the moon, maybe further, what do your analysts think as they begin to assess this about the possibility of conflict, that the kind of colonial wars that we read about in science fiction could be part of our human reality?
Yeah. Well, first of all, not surprisingly, we're trying to avoid any colonial wars in space. But beyond that, this is, first of all, I mean, I think from our perspective, we don't see it as this sort of separated and isolated domain. To the extent that there's going to be a conflict, it is far more likely that we have a situation where it's a conflict on Earth and it's a conflict in space, and the two are connected to each other. And so we work through essentially scenarios in which we identify, here's a variety of ways in which we can integrate deterrence, which is our classic way of essentially managing conflict. And in that context, I think, you know, we're consistent in saying to the policy community as they think through what are the sort of strategies for dealing with this, that if you want to affect deterrence, you can't just think about it in space. You've got to think about it in an integrated way across all of the different domains in which you're likely to engage in conflict. So that's one aspect of it. But another aspect of it, too, I think, is just that space is a domain in which we obviously have some treaty law. There were sort of 6 main treaties in the 1960s. There have been a variety of international efforts and norm making over the years that have developed. But it is still, in some respects, quite nascent, which is to say that there's a lot of additional work to be done to create the frameworks that will ultimately, I think, be relied upon in space. And there's also a lot that's changed. It used to be, when many of these normative frameworks were established, it was a very state-dominated area, which is to say it was really only governments that were effectively in space. And the reality is today, the commercial sector is just blooming in space and considerably spanning a fair amount of the government work, and governments are working with industry. And that is going to take a different kind of a framework, and that has created some kind of evolutionary aspects of these normative frameworks. But I think we're really just at the beginning of that, and looking at how it is that we actually develop a framework for space that makes sense. So that is, I think, going to be a part of what we'll be seeing in the future, and thinking through what some of the costs and benefits are of different frameworks, how we evolve, how we promote a situation that allows us to basically benefit from the greatest opportunities that are available to us in space, of which the commercial industry and private sector is an enormous part of what I think will be beneficial to us in the future, and leading in the innovation in many respects. And that's something that we need to be able to inculcate, to facilitate, to support moving forward. So I think that will be some of what we see in the future.
So, Matt, a final question for Senator Nelson. Senator Nelson, last question. What's the coolest thing about NASA that we don't know about?
Well, it's classified.
Good answer.
No, I'll tell you one example that you don't know about, but it is really neat. If any of you saw, a couple of decades ago, the hit movie Armageddon with Bruce Willis, there's an asteroid in the movie that's headed to Earth that will destroy Earth. And so they send a crew. I mean, it was big time fiction, because they sent in the movie a space shuttle up there, which you can't do. And then, of all things, they used a nuclear weapon to move it out of its path. We're doing this real time come December. It is a mission called DART. And it's going to an asteroid that is orbiting an asteroid. And we're not going to hit the big asteroid. We're going to hit the little asteroid. But oh, by the way, the little asteroid is the size of 1/4 of a mile in diameter. And we're going to hit it with a probe at 16,000 miles an hour. And then we're going to watch it in our telescopes. Did it move it ever so slightly in its orbit around the other asteroid? And if that's successful, what it will tell us is, if we did detect an inbound asteroid that could threaten our existence as a planet, that then we could send a probe, and that probe would ever so slightly change its trajectory. The further out that you can get that hit, the better chance of changing that trajectory so that it misses planet Earth.
Well, that's pretty cool.
I can't beat that. I hope
Well, I'm going to ask you the same question, D&I Haynes. What's the coolest thing that the intelligence community is doing in space that we don't know that you can talk about?
I don't think there's really anything. I'm going to get fired if I talk about the coolest thing that you don't know about. I will tell you that we work with other countries and their private sector, in addition to our own private sector, on a variety of things. And like New Zealand with rocket launch, or a variety of other places. And we do some absolutely amazing things. And honestly, if folks are interested, they should come work at the intelligence community. That would be my answer to that. So we have some phenomenal stuff that we will show you once you get your
So if
clearance.
you want to know the cool stuff, you've
Yes.
got to go to work for the United States. So I just want to thank her for joining us. I want to thank Senator Nelson for coming to us from the fourth dimension. And with that, I want to ask my brother Adi Ignatius to come on stage with our surprise guest, Jeff Bezos, for our next discussion.
Fantastic. Thank you so much.
That was super.
Thank you.
Just-
All right, we have a tough act to follow.
Yeah, that's going to be hard.
Yeah. So there are a lot of conversations that one would like to have with Jeff Bezos about Amazon, about the future of retail, about climate change, but today we're talking about space. Jeff Bezos, the founder of Amazon, also is the founder of Blue Origin, a private company that manufactures space vehicles and conducts space flights. The company's stated goal is to make access to space cheaper and more reliable through reusable launch vehicles. We really are thrilled that you're here and want to talk to you about your interest in space, your vision for space. This past summer, of course, Jeff went to space himself on Blue Origin's New Shepard rocket, an experience that he says changed him. So Jeff, welcome, and thank you very much for being here.
Thank you. It's great to be here.
All right, let's do it. So when you returned to Earth from your trip to space in July, you were quoted saying it was best day ever. Give us a little more about that. Tell us about, describe the experience of leaving Earth's atmosphere.
Well, very much what Administrator Nelson said. Everybody who has been to space tells you that they experience something that has come to be known as the overview effect. And I thought Senator Nelson did an amazing job describing that. I was expecting that. And I wanted to feel that, and I was ready for it. And what I can tell you is that the magnitude of that experience was so much bigger than I could have ever anticipated. And it really is such a change in perspective that shows you, in a very powerful and emotional way, just how fragile this Earth is. And I wish everybody could have that perspective. We've sent 8 people up so far, and we hope to send many more. But each one of those people comes back an ambassador for Earth. And it's a very dramatic feeling. We sit here, and the atmosphere looks so big, this planet looks so big from the ground. But up there, what you see is the immense blackness of space, this tiny little cradle. In fact, that's why the name Blue Origin, our origin is this blue planet. And this is the most precious planet in the world, and we have to preserve it and conserve it and make sure that our children and their children and so on have this beauty in their lives.
Yeah, talk about how, what's the origin of your interest in space, your passion for all of this?
Well, I was 5 years old when Neil Armstrong stepped onto the moon. And that made a huge impression on me. I grew up reading science fiction. I grew up watching Star Trek. In 4th grade, my neighbors, Dean and Kyle, the 3 of us would play Star Trek all summer long. And, the dreamers come first. If you read science fiction, you watch other people, you get inspired. And the dreamers inspire builders, and the builders build, and they make new foundations that the dreamers can dream even further, and that cycle continues. And that's certainly what happened to me. I've been passionate about space my whole life. In high school, the speech I gave at the end of the year, I was completely about space, and the last words of the speech were, "The final frontier, meet me there." I've always wanted to turn the Earth into a sort of, national park or something zoned light industry and residential. And I think most heavy industry will be done off in space.
So I want to come back to that for sure. I read a quote somewhere, it was a high school friend of yours who told the media that she figured you started Amazon just to be able to raise enough money to create a space business. Does that sound about right?
That's my high school girlfriend, Ursula, who has been quoted a few times saying that in the press. And it is extremely handy to have a lucrative day job if you are going to have a very expensive night job. And that's what Blue Origin is for sure. So yes, that's worked out very well.
But let me push on that. I mean, did you actually see, if you were successful in business, that would give you the resources to be able to do?
Yes, I've always had that dream of building a company like Blue Origin to pursue this, what I think is building a road to space. I can talk about that for a long time, but I'll...
Yeah. Okay, amazing. I want to ask, so there are, plenty of critics who will say that, the people in the private sector are spending so much money, in space. We have lots of problems on Earth. Shouldn't those resources couldn't they be used more effectively to solve the problems on Earth rather than, these sort of fantastic ventures into space? What do you say to that?
I say they're missing the duality that we need to do both, and that the two things are deeply connected. I'm actually spending even more money on the Bezos Earth Fund than I'm spending on space, and that is about climate change and about nature and conserving nature and using natural solutions to help climate change. About $3 billion of the $10 billion in the Bezos Earth Fund is going to go for nature-based solutions. We need to conserve what we still have, we need to restore what we've lost, and we need to completely transform our food systems and grow what we need to live in a new way that doesn't degrade the Earth. So there's a tremendous amount to be done in the here and now, and we cannot forget about that. But at the same time, in a deeply connected way, we need to look to the future. And we humans have always done both things. We've always looked at the here and now, and we've always looked out to the future. And this planet is so small. If we want to keep growing as a civilization, using more energy as a civilization, most of that in the future needs to be done off planet.
I do want to come back to that too. You mentioned your interest in Star Trek, and I don't know if people know that some do, I'm sure, that you played in the 2016 movie Star Trek Beyond. You played an alien with appropriate makeup. I wanted to ask
that was not an easy gig to get.
Well,
I insisted on a speaking role, which complicated the whole scenario.
What did you say?
Speak normally. It was one line.
Yeah, you got it.
I nailed it.
Yeah, sounds like it. So what was it like then having William Shatner, who was Star Trek's original Captain Kirk, on Blue Origin's most recent human flight?
Well, it was incredible, and I didn't really know William Shatner very well. I'd met him a couple of times briefly. I knew Captain Kirk, and of course, sometimes it's confusing, but you guys may understand that Bill Shatner and Captain Kirk are not the same person. And so I feel, he came down, and I opened the hatch, and he came out of that capsule, and he was almost catatonic. He could barely speak or even move, and he stood there for a few moments, and he sort of collected himself. And when he did start to speak, it was one of the most moving experiences of my life. He was so emotional. There were tears streaming down his face, and it was transformational for him. I think, upon reflection, that we each gave each other the gift of space. He gave it to me when I was in 4th grade, and I gave it to him when he was 90 years old. And he has been the best ambassador for looking at this planet and that transformation that he experienced. He will tell you, very much like Senator Nelson did, that it's blackness, it's nothing. He called it death. You get up there and you see this, looks like there's nothing, it's death. And you look down and there's this jewel that's just vibrant with life, and it's so precious. It's the only place like that for sure in our solar system, and maybe for many, many light years around, we don't know. But it's very precious.
What's your guess, for people in the audience, let's say younger people, in their lifetime, what are the odds that they will have the opportunity to experience a flight like you did?
This is where we are right now is the barnstorming era. So this is, small, the barnstormers of the past would take their biplanes and land in farmers' fields and take people up for a few minutes so they could experience flight. And back then, you would have had a hard time, or even earlier, if you were there at Kitty Hawk when you saw Wilbur and Orville fly, you would have had a very hard time imagining 787s and Airbus 380s and commercial aviation as we know it today. And that's what has to happen. That is what's happening. So when New Shepard, when we take these people up on a short flight, the flight only lasts 11 minutes. You're in 0G for 4 minutes. But you see this incredible transformative experience. You come down, and that's the barnstorming era. We need to build vehicles that are completely reusable in the next generation, so that we need to get to the 787 of space travel. When we do that, that will unlock this experience for millions of people.
And would you even hazard a guess? Is that in your lifetime?
I hope that's in my lifetime. So the goal at Blue Origin is to build a road to space so that the next generations can build incredible, things in space. Solar power generation stations, huge computational fields, giant colonies where millions of people can live. I know that sounds fantastical, but believe me, if you had been there with Wilbur and Orville, you'd have thought the 787 was a fantastical idea too. These fantastical ideas do come true. They absolutely do come true, but you have to create the preconditions for them to come true. And what we need with launch vehicles is not just reusability, but operational reusability. It has to be just like a commercial airliner: land, refuel, fly again. It's impressive as a technical achievement as the space shuttle was. It was not an operationally reusable vehicle. It took way too much inspection between flights, way too much refurbishment between flights, and it turned out to be very expensive. We need to dramatically reduce the cost of space. That infrastructure building will unlock future generations to do amazing things in space. It's very much like when I started Amazon, I got to rely on infrastructure. I didn't have to build a package delivery service. It existed. It was called the US Postal Service, and Deutsche Post, and Royal Mail, and UPS, and FedEx. So we could rest on top of that heavy lift infrastructure. And that's what I want Blue Origin to do in my lifetime, is create that road to space so that future generations can build life in space.
So you've talked about, your vision.
And it's not to leave the Earth, it's to save the Earth. This is one of the things that I see people consistently get wrong, at least from my point of view. This is the precious planet in our solar system. We need to be able to go to space so that we can preserve this planet. We have already lost so much forest, so much river, the nature that we've lost. We need to restore that. And we can do that and maintain the things we love about our modern lives. But we need to do that, we need to be getting our resources and doing our heavy industry off Earth, which that may not happen in my lifetime, but I can create the preconditions so that the next gen can do that.
So you've talked about, moving large numbers, and I'd like you to talk about what kind of numbers we're talking about, of humans from Earth to large, complex space colonies. And I guess now I really want to hear more. What is the imperative for that? And what would these colonies look like? What would they do? What's the vision here?
Well, the imperative for that is we will be at a crossroads. This Earth can support, let's say 10 billion people to a certain degree. We'd have to really work hard to figure out how to do that without continuing to degrade the planet. But this Earth can support 10 billion people. The solar system can support 1 trillion people. And we can continue to grow our civilization and grow our energy intensity. So if you look throughout history, one of the most striking things you see is that energy usage per person has been continuously growing, and the compound rate has been around 3% a year. And if you compound our current baseline energy usage at 3% a year for just a few hundred years, you have to cover the entire surface of the Earth in solar cells. And we want to continue to use more energy. It's one of the things that gives us the modern life that we enjoy. The medicines and hospitals, the miraculous things that we're able to do with, figuring out the mRNA vaccines and all the computation we use and so on and so on. We want to be able to, all other things being equal, we would love for our energy intensity to continue to increase on a per person basis. We want people in developing countries to have the same energy gifts that we have enjoyed and to continue that for future generations. If you stay here on Earth, that cannot be allowed to happen. We will ultimately, because this planet is finite, and if you see it from space, you'll know it in your heart, not just with your head. Because this planet is finite, we will end up with a system of rationing where there will be a limited amount of energy that we are allowed to use per person. And on this planet, because it's finite, that probably one day makes sense. It will happen. Energy will just get very expensive when the true costs are calculated. But off-planet, where the sun shines 24 hours a day, you can build gigantic solar farms in space. You can beam some of that energy down into Earth. Most of it will be used in space. If you look at the asteroids and near-Earth objects and the moon, we have so many resources out there. We don't need to strip mine Earth to get those resources, and we don't even need to bring most of that back down to Earth.
So we're used to thinking of, a few people at a time going up to space. You're talking about massive numbers, and are you talking about planet-based colonies or orb-based colonies?
Even if you were to terraform Mars or do something very dramatic like that, which would be very, very challenging, by the way, even if you were to do that, that is at most a doubling of Earth. Then you're going from 10 billion people to 20 billion people. If, on the other hand, if you build these large colonies, each colony may hold 1 million people. This is an idea first investigated by a Princeton professor named Jerry O'Neill, who asked his students a question, a very fundamental question, which is a planetary surface the right place for humanity to expand in the solar system? And kind of to his surprise, he and his students, after evaluating this, decided no, it probably made more sense to build colonies. These colonies are miles long, they're rotated for artificial gravity, they're probably near Earth so that you can return to Earth when you want to. I think in the foreseeable future, people are not going to want to leave Earth vicinity. It's going to be nice to be able to come home every once in a while. This place is special. We can't ruin it.
So if this happens, again, I'm interested in your sense of the numbers of people. We're talking, thousands, hundreds of thousands, millions, hundreds of millions.
Well, millions of people will move from Earth to space over time, and that's the vision of Blue Origin, millions of people living and working in space. But over centuries, many people will be born in space. It'll be their first home, and they will be born on these colonies, live on these colonies. They may visit the Earth the way you would visit, Yellowstone National Park.
Who gets to stay on Earth?
And these colonies will not be like the International Space Station. They will be, they'll have rivers and forests and wildlife, and they're places where you can use a lot of energy and not be damaging this fragile planet.
So what's the great sort of technological breakthrough that would need to happen for this vision to become real?
The first thing you need is reusable spacecraft to get this bootstrapped, and operationally reusable spacecraft. That's it. That's the very first thing you need. That's the gate through which everything has to travel. If you don't have that, you can't do any of this. And then the next generations will figure out the next steps. But we know some of them, you're going to have to use in situ resources. These colonies are large enough that you're not going to want to build them from materials here on Earth. You want to build them in space.
So we're used to seeing governments sort of run space programs and colonize space to the extent that that's happening. Blue Origin, obviously a private company. You develop your own moon lander. Help us out. Should we be comfortable with the idea that the private sector is playing such a forward role in the future of space?
Yes, I think you should. I mean, I think the government will still have a role to play, but they should be doing the really hard things. You know, when we're talking about launch into Earth orbit, that is something which is now within reach of private enterprise in a very commercially sustainable way. And that is something then that should be transitioned to the private sector, because the private sector can be very dynamic and make very rapid progress. You know, you don't need a government program to make the next generation of iPhone. Apple seems to be doing a pretty good job of that, and they have the competition to do it, and they have Google and Samsung and others, and that competitive cycle drives that technology forward at a very fast rate. So you want that to happen in space as well. That's what sets up this opportunity to have this big entrepreneurial dynamism in space. At the same time, there'll be really hard things to do that have time frames that commercial investors are not willing to invest in, and those will continue to be the domain of governments. So, you know, planetary research missions and so on, hyperspace, you know, point-to-point travel perhaps, those kinds of things will continue, I think, to be in the realm of government. And there will be public-private partnerships too, where you see some of those two things cross. All of that's good.
So we've already teed up the question of you know, whether or not there's life out there, and we'll be talking about it more later, but I'm interested, what are your thoughts?
How could there not be? I mean, it just seems, there's so many stars just in this galaxy, and then so many galaxies. The odds that we are the only intelligent life in the universe seem vanishingly small to me. Now, if you ask me, have we been visited by those extrasolar intelligences, I very much doubt that. I think they would be, you know, we would know if we had been. But are they out there? Probably.
Yeah, and you don't feel like if they're out there, how could we not have seen them?
No, these distances are so vast, and there are so many unanswered questions about how many of them there are, how long those civilizations last, what their interests are. Some of them may, you know, just not be that interested in leaving their solar system.
Mm-hmm. So Blue Origin has a number of flights under its belt, a lot of work under its belt. I'm interested, what has surprised you both positively and maybe negatively? You know, what's been a bigger challenge than you anticipated, but what has pleased you so far?
Well, the hardest thing by far is that operational reusability. So if you look at New Shepard is our suborbital tourism vehicle. It's the vehicle that we've now flown humans in twice, and we want to make, you know, hundreds and thousands of those flights, and the reason we want to do that is because we humans get good at every single thing we practice. And so the more we fly that vehicle, the better we will get at it, and we'll learn how to have really operational reusability. And then that vehicle, everything we have already learned with that vehicle and everything we will continue to learn with that vehicle is being incorporated into our orbital vehicle, which is called New Glenn, named after the first American to orbit the Earth, John Glenn. New Shepard named after Alan Shepard, the first American in suborbital space. And so that's really, that's the hard part is not space travel, right? That was a solved problem in the 60s. Not reusability, the space shuttle sort of did that. The hard part is operational reusability. And it is a hard technical problem. And it requires practice to get it right.
I guess, you know, I'd love to hear more about what's next for Blue Origin. I mean, we've been amazed. We've seen these flights. We've seen, you know, you on them and Captain Kirk. You know, what will we see in the next few years? You know, what can we expect?
We're going to continue to fly New Shepard, you know, much more frequently, hundreds of times. We're building new tail numbers for New Shepard, and it is every time we fly, we're going to bring back ambassadors for Earth. And that's what we find is everybody who has flown has had that profound emotional transformation that William Shatner, you know, voiced so well, that I felt so deeply myself. Every single person who's gone has felt that. So we're going to continue to make more ambassadors for Earth that way. We're going to continue to practice. we're building New Glenn, which is a very large orbital vehicle that will ultimately be fully reusable and operable, and that will unlock a tremendous amount of opportunity in not just low Earth orbit, but also in the kind of lunar vicinity and beyond in interplanetary terms. So that's the next step.
Yeah, amazing. So you mentioned William Shatner again. I had meant to ask, so when you played Star Trek in 4th grade, were you Kirk?
We always, the two most popular characters that we arm wrestled over were Kirk and Spock. And it sort of depended on the day whether whether Dean or Kyle or myself got to be Kirk or which of us got to be Spock. Where somebody also was Bones, and somebody would be the computer. The computer wasn't a bad role to play either.
Right. And I guess my other last question is, on these space colonies, can you get Amazon Prime?
Of course. Are you kidding? That'll be built in. Amazon hypersonic delivery. It's coming soon to you. So.
Okay.
Yeah. It's on Bill Shatner, I just want to say it was so amazing to watch him have that transformation, and to have him go up as Will Shatner, and then for me personally to have him go up as Captain Kirk, and for me personally to have him come down as Bill Shatner was a very moving experience for me.
Perfect. All right, we are out of time, but I want to thank you very much for taking part in this and for sharing your vision. It's fascinating.
Well, it's been great, and it's one step in front of the other. The grand vision will take a long time, but big things start small, and this is how it starts. Thank you, guys.
Fantastic. All right, so we're going to depart, but I want to invite the next trio to come up to the stage. So it's Dr. Avi Loeb, who's professor of science at Harvard University, Reverend Professor David Wilkinson, who's principal at St. John's College at Durham University, and the moderator for this session will be Dean Randolph Hollerith, who you've met before, the Dean of the Cathedral. So come on up.
Thank you, that was great.
Thank you, Adi. Thank you, Jeff. That was a really wonderful conversation. Thank you, David, Averill, for such a wonderful beginning to our evening tonight. I'm thrilled to have with me in this conversation, two folks who have an incredibly long bios, and I'm going to chop them up to be quite short. But I need to share something about the achievements of these two amazing individuals before we begin our conversation. So David Wilkinson is principal of St. John's College, Durham University in the UK, and project director for Equipping Christians for Leadership in the Age of Science. And before working in Durham as a professor and theologian, he was a scientist and then a Methodist minister in inner city Liverpool. He earned PhDs in astrophysics and systematic theology, demonstrating his long interest in the dialogue of science and religion. His current work involves the relationship of Christian theology to contemporary culture. He's published several books, including The Power of the Force, The Spirituality of Star Wars Films. So we got Star Trek and Star Wars in tonight, which is great. And Science, Religion, and the Search for Extraterrestrial Intelligence from Oxford University Press in 2017. Avi Loeb is the Frank B. Baird Jr. Professor of Science at Harvard University and a best-selling author. He received a PhD in plasma physics at age 24 from Hebrew University in Jerusalem and was subsequently a long-term member at the Institute for Advanced Study in Princeton, where he started to work in theoretical astrophysics. In 1993, he moved to Harvard University, where he was tenured 3 years later, Loeb is the current director of Harvard's Institute for Theory and Computation, founding director of Harvard's Black Hole Initiative, and the longest-serving chair of the Harvard Astronomy Department. Loeb has authored more than 800 research articles and 8 books, including his most recent in 2021, Extraterrestrial, and also Life in the Cosmos. So gentlemen, thank you for being with us today, and thank you both for coming, David especially, such a long distance to be with us. I think you were one of the first plane loads of folks reconnecting the UK and the United States post-COVID, so thank you for doing that and being with us. Dr. Loeb, we're honored to have you as well. So I'm going to jump right into it because our time is quite limited here tonight. So I'm going to start with you, Dr. Wilkinson. As a scientist and as a theologian, why should science invest time and money in the search for extraterrestrial life? And why, second part of the question, and why should religious people care one way or another?
Well, thank you. It's good to be here. And of course, at this point, a number of friends will remind me that Giordano Bruno was put to death at the stake in 1600 for speculating on other life, a mistaken claim, and that Thomas Paine wrote that those who speculate about other worlds and Christianity know little of either, which sums up my academic career, I think. But I'm fascinated by this topic for a number of reasons. When I flew in at border control, which I wasn't too sure whether I was going to get through because of COVID, after an hour of waiting with hundreds of people in the arrivals hall, the person who was checking my passport was far more interested in talking about God and aliens than anything else. And I think there's a fascination with the question. But then as a scientist and a Christian, I go back to my own excitement both with the Christian faith and with science. Christians have speculated about other worlds for generations, back to Origen in the 3rd century, when he talked about other worlds. And that's partly because he just knew that the universe was extravagant as a creation of God. Now, some Christians then got worried about human uniqueness or the Jesus event, but there were people like Galileo and others who built telescopes because if God was free to create, then you couldn't work out the universe by simple logic or philosophy. You had to look at the universe, observe it, as Kepler said, to think God's thoughts after him. And I think then there's something about the fact that as a scientist, I want to affirm curiosity. And I find that science is a gift from God, that actually exploring the universe, as Avi has often pointed out, gives us a sense of humility. And for me, that's a religious as well as scientific experience. The sense that an encounter with the other tells us something about ourselves. And the encounter with the big questions is a reminder of humility. So I don't think that Christians should be worried about this at all. I think there are interesting questions which we may come on to, but I'm excited and committed and passionate about it.
Thank you. Now, so Dr. Loeb, just jumping right in with you as well, you recently released a book called Extraterrestrial, The First Sign of Intelligent Life. Incredibly fascinating book that has sort of taken the world by storm. You've gotten quite a bit of attention around your work and your theories. You describe what you call the first interstellar visitor to our solar system that was first detected in 2017. And this object is named in Hawaiian, I'm going to butcher it, Oumuamua?
Oumuamua.
Oumuamua in Hawaiian, which means first messenger from afar. And your research, if I'm correct, into this interstellar visitor has created quite a stir because you don't think it's a comet or a meteor or an asteroid that has come through our solar system, but a spacecraft or an alien artifact that has been traveling towards us for perhaps millions of years. Tell us more about your thinking.
Well, I see science as a continuation of our childhood curiosity. I remember very vividly sitting at dinner and asking a difficult question. And the adults in the room would dismiss that question. And that bothered me, because they really didn't know the answer. They were pretending to portray an image of authority. And I thought that by becoming a scientist, I will be given the privilege of asking difficult questions and perhaps even answering them with data, because it's a learning experience. And I should say that I'm humbled to sit with two religious authorities, because as I studied the universe, I realized that some of the important principles that I uncover were part of religion in the past. First of all, when we look at the universe, we realize, that we are not central actors in this play. The play started 13.8 billion years ago. We just came at the end. How dare we think that we are the main actors? And moreover, we are not on the center of the stage. I mean, it was very impressive to see Jeff lifting his body by 1% of the Earth radius. But the universe is 10 to the power 19 bigger than the Earth radius. And that gives you a sense of modesty. The second thing is, we can be curious about how we came to exist on this planet and whether similar circumstances could have led to something similar to us. One thing I tell students in my class at Harvard, on the first day, I tell them, half of you are below the median. And they're shocked, because coming to Harvard, they believe that all of them are in the top 1%. But the definition statistically of the median is that half of the students in the class are below it. And if we look at ourselves, we definitely behave as if we were below the median of intelligent civilizations out there. And the last thing is, when you see the big picture, you get a sense of calmness. We are preoccupied with what's happening here, impressing each other. When you look at the big picture, it's not so relevant. So I have a twist on religion that I would like to introduce, if you allow me. Please. First of all, we are almost developing life in our laboratories. We are able almost to produce synthetic life in some laboratories on Earth. And so God, in many religions, was the creator of life, was the creator of the universe. If we, in the future, understand how to unify quantum mechanics and gravity, we might even be able to create a baby universe in the laboratory. So my point is simple. An advanced scientific civilization could be an approximation to what we called God. And the second point is, religions argue that humans were created in the image of God. Well, I would argue that we are now developing artificial intelligence systems that are in our image. So in the image of an advanced technological civilization, you will have AI astronauts. I don't think we should send people to space. We were selected by Darwinian evolution to survive on the surface of this rock. And in space, there are many hazardous conditions. We should be proud of our technological kids, these AI systems that drive cars right now, and in the future, they could be astronauts. So instead of sending millions of people to space and endangering their health, we should send our kids, technological kids, AI systems into space. Now, if we can imagine doing that, someone else might have done it, because most of the stars formed billions of years before the sun. So my point is simple. Let's look at the sky and check if there is any equipment, AI astronauts, that were sent by other civilizations. And that's the goal of the Galileo project that we established a few months ago, that received private sector funding, and we plan to use telescopes and look at the sky. Because if we don't look through our windows, we can argue that we don't have neighbors, but that will not get rid of our neighbors. And Oumuamua was the first interstellar object that came from outside the solar system that was spotted near Earth in 2017. It didn't look like a comet or an asteroid. It looked very weird, and I talk about it in my book, Extraterrestrial, at length. And my point is, let's get a high-resolution image, a megapixel image of an object like it, and figure out whether it has screws and bolts, whether it has buttons that we can press, or whether it's a rock. Because all the suggestions made by my colleagues, astronomers, were of something that we've never seen before. And you know, if you imagine a caveman finding a cell phone, the caveman would say, oh, this is a rock of a type that I've never seen before. But that's just the beginning of a learning experience. And my point is, let's embark on this learning experience. That's what the Galileo project is all about.
Thank you so much. There's so many questions that I have right on top of that, but I'm going to try to go back and forth between the two of you because I'm so grateful to have you here. So, Dr. Wilkinson, with some branches of our faith, with Christianity, with the Abrahamic faiths, there's a belief that, as Dr. Loeb said, that human beings are the pinnacle of God's creation. If we were to discover advanced, intelligent life on another planet, would that dislodge our place in God's creation? What would that mean for how we understand what I like to say are the truths of Genesis?
Yes, a number of people have worried that if we do discover other life, and particularly intelligent life, then our uniqueness and our special nature, our special relationship with God would be undercut by that. And that partly is because we've always believed that we're at the center of everything. We're the pinnacle of everything. But in the 15th century, a Christian theologian called Nicholas of Cusa said, within the Judeo-Christian tradition, you are special not because you're at the center of everything, but because you are loved. The belief that God loves us. So when I'm sitting with my family at home, I don't have to sit at the head of the table to feel special. I can sit wherever I want. It's the relationship of love that makes me feel special. And indeed, it's not an exclusive relationship of love. The God that I see in Jesus Christ, I think, is a God of love and grace. And that God would be loving not just to human beings, but loving to the whole of creation, the planet itself. And if there is other life, intelligent or not, that would be the basis of a relationship of love. So I don't think human uniqueness needs to be defined by the fact that we're the pinnacle of everything or that we're the center of everything. And I think that's where the encounter with the possibility of other life becomes really interesting, because we've often in history defined ourselves against the other, defined ourselves as the most important. Something about even the discovery of microbes on the surface of Mars would be a reminder that actually this universe is far more interesting. And indeed for Christians, that God's interest is far more than just human beings.
And I would dare say that this is all a piece of that great humility that Jeff Bezos is talking about in the experience of looking at our fragile Earth, as well as Bill Nelson's comment, is that it does humble us as to our place within the cosmos.
The experience of awe, coupled with the experience of a precious gift of this earth, I think is both inspiring and humbling. And I think that view of life in a different way, that overview, as Jeff talked about, is really important. I've not been to space. I'd love to someday, but I love roller coasters. And my wife and I love roller coasters, and we remember going to a theme park where there was one roller coaster in England called the Big One. We arrived at the theme park, there was no parking spaces anywhere. We drove round and round and round, couldn't find one. We were having an argument. We eventually got to the roller coaster, we weren't speaking to each other. We got on the roller coaster and we went up that first hill. Most people look down at the big drop when you get over the first hill. But let me tell you, if you go to England and you go to a place called Blackpool and you go onto the roller coaster, the big one, and when you get to the first hill, instead of looking down, you look over your shoulder, you will see so many parking spaces you will not believe. I mean, parking space after parking space after parking space. Those things which look at one level to be problems are given a different perspective at another level. And so overview doesn't take away problems, it defines things in different perspectives. And that's the wonder of space for me.
Can I steal that whole thing for my sermon on Sunday?
At a price.
At a price. Dr. Loeb, I think your whole book and your conversations about, I'm going to mispronounce it again, Oumuamua. I practiced pronouncing it about 5 times, but I practiced pronouncing it wrong from reading the book, so I can't get the wrong out of my head. If you think about Oumuamua and what it could be and what it might mean for our need to pay attention to the cosmos, what do you think about some of the things that Albert Haynes was discussing, or that David was asking her about, these objects that have been tracked by our pilots, the videos most recently released the past couple of years that cover the New York Times, all of that. What do you think about those experiences?
Right. Well, first I should say that during the Jewish high holidays this year, I got an email from a rabbi in Ann Arbor, Michigan, that gave a sermon about my book. So the sermon was given. But with respect to your question, that's the second branch of the Galileo project. We would like to take high-resolution images of unidentified aerial phenomena and figure out what they are. Because it's not a philosophical question. If you have good enough data, you can tell. And if we read off the label with a large enough telescope, we can read off the label that says, made in China, made in Russia, we will gladly deliver the information to Avril. I don't care about that as much as I don't care about a high-resolution image of a bird. I would deliver that data to a zoologist. These are boring as far as I'm concerned as a scientist. I mean, I know that Avril really very much focuses on those. But for us, something unusual would be intriguing. And, you know, it's a fishing expedition. If we find only sardines, so be it. I should say one thing about humans. I mean, we talked at great length about the good qualities of human, but if I look at human history, the one thing that strikes me is that the source of all evil is the human ego. And the best example is the Second World War, where the Nazi regime triggered the death of 75 million people. That was 3% of the world population in 1940. 20 times more than the number of deaths triggered by COVID-19. Just think about it. 20 times more because a group of people decided to feel superior relative to other people. And my point is simple. Suppose we find a smarter kid on our block. Then all the small differences between us are meaningless. Showing off in space is an oxymoron. And my hope is that once we discover intelligence out there, we will treat each other with more respect as equal members of the human species.
Amen. That's another good sermon. Thank you. So 3 questions for both of you, very straightforward. I think I know the answers to a couple of them for each of you. 1, do you think we will discover life in the universe, just basic life in the universe? 2, do you think we will discover intelligent life in the universe? And 3, are we being visited now by intelligent life? David, you want to go first?
And those are simple questions, are they?
Right.
I think we will discover primitive life elsewhere in the universe, and I think that'll be exciting. I don't know whether we'll discover intelligent life. As we've mentioned already this evening, one of the problems is that of communication. So if there's a civilization in one of our nearest galaxies, it may take a message a few million years to reach us, saying, hello, is there anyone there? If we send a message back saying, yes, we're here, who are you? That's another few million years to get back. That's not a very interesting conversation. And as Avi has said, in terms of the scale of the universe, it may be that there's intelligent life out there who we'll never contact or know. But it doesn't worry me if we do. I think that'll be a really interesting encounter. And the third question was, have we been visited? I don't think so. As that great prophet of space, Elton John, once said, any rocket man has to come a very long, long way to reach us. And being British, if I'd arrived, I think I would probably call in for a cup of tea after such a long journey. So I think, but I do want to affirm Avi's project, which is about looking for the evidence, both as a scientist and as a Christian, to be open-minded, not to rule things out, but to do science well. And science is about engaging with the question. And the God that I believe in, I think, encourages us to do that, affirms science as a gift, and affirms asking the questions.
Thank you.
So let me go back to two things that happened 70 years ago. One of them is the famous physicist, Enrico Fermi, had lunch at Los Alamos with colleagues. And they discussed extraterrestrial life. And he said, well, if it's very natural to have life out there, where is everybody? Now, that's a very presumptuous question. It's just like sitting on the sofa at home and saying, nobody is knocking on my door, therefore I don't have neighbors. Recorded history of humans is 10,000 years old. That's 1/1,000,000th of the age of the Earth. So how dare we say we don't hear a knock on the door right now, therefore we don't have neighbors? It makes no sense whatsoever. And besides, there is this story about a fisherman that came back from sea and said, I discovered the new law of nature. All fish are bigger than 2 inches. So a friend of his asked him, what's the size of the holes in your fishing net? And he said, 2 inches. And my point is, Fermi did not use telescopes to look at the sky. He just wanted them to show up in his front porch and communicate. The point is, suppose there are AI systems that are small. Now, the Oumuamua, this object, was the size of a football field. It was discovered in 2017, just because a few years earlier, we had the first survey telescope that could detect the reflection of sunlight from an object the size of a football field that passes within the orbit of the Earth around the sun. Before that, we didn't have that. So obviously, Enrico Fermi used a fishing net that has holes that are too big. He couldn't see that. And the second point is, if these are AI systems that may be astronauts visiting us, not biological creatures, we might need our own AI systems to figure them out, sort of like relying on our kids to interpret content we find on the internet because they're more computer savvy. And that's a new technology that we can now use to figure out what's going out there. Now, the second thing that happened 70 years ago was that we decided we have radio communication. We had it for, by now, 126 years, since Marconi sent the first transmission. And we say, OK, we transmit radio signals. They must transmit as well. Let's look for them. But that's just like trying to have a phone conversation. You need the counterpart to be active. And if they lived for a short time, as Jeff was pointing out, they might not be around anymore. You can't have a phone conversation with an ancient culture on Earth that is not around anymore. And a much better approach is to do archaeology. Here on Earth, search for relics that they left behind. And in space, it means looking for equipment that they sent and that kept accumulating in space, just like plastic bottles on the surface of the ocean. That's what the Galileo project aims to do. Search through telescopes for equipment floating in space. It sounds to me common sense. And with $100 million, we should be able to say something very interesting on this question. And that's what I hope to raise.
I think that is a fantastic project and something that I will love to watch from a distance. There's no way to wrap this up because I have 85 more questions for both of you, but I'm getting flashed about our time limits here. I just want to end on the faith note, if I might, as a bias on my part. But you, Dr. Wilkinson, you say that the search for extraterrestrial life is the biblical prime directive. What does that mean?
Kepler once said that science is thinking God's thoughts after him. And so part of the gift of curiosity, for me that's been made in the image of God, is the ability to ask questions of God's creation. That's what happened in my own life at the age of 17 when I became a Christian, and I found that science was introducing me to the things that this God had created, particularly the laws of physics and the beauty and elegance of the laws of physics. And I think that there is something about exploring the heavens to be surprised, both as a scientist and as a theologian. For the God that I believe in is a surprising God at times, and he breaks the insularity of some of my prejudices and some of my preconceptions. And therefore I think I want to be a supporter of SETI, a supporter of Galileo, a supporter of space exploration, because it's thinking God's thoughts after him.
If I were to add to that, let me just spend a few seconds on the origin of the name Galileo. It comes from the northern part of Israel, Galilee. And in Hebrew, Galilee means a cylinder. So if anyone read Arthur C. Clarke's Rendezvous with Rama, a cylinder is meaningful in this context. And, you know, it may not be a cylinder, but we actually, the same telescope that discovered Oumuamua, pan-stars in Hawaii, discovered in September 2020, just a year ago, another object that exhibited similar anomalies. It was pushed away from the sun by reflecting sunlight and didn't have a cometary tail. It was given the name 2020 SO, and it was realized a few weeks later that it actually came from Earth. It's a rocket booster that we launched in 1966 as part of a lunar lander mission. And it was cylindrical. And we know that we produced it. The question is, who produced Oumuamua?
Great question to look for those answers. Thank you both so much. I'd like you to join me in thanking all of our guests tonight. Thank you for staying with us and for being here. And if you are a person of faith that's important to you, I would love to just be able to offer a quick prayer as we leave tonight. So may the Lord bless you and keep you. May the Lord make his face to shine upon you. May the Lord lift up his countenance upon you and grant you peace. Amen. Thank you to the Ignatius family. Thank you to all of you for being here tonight.